Welcome to homework.
We are given languages, and we are asked to find phrase structure grammars for each of these languages. In part A, we're given this set consisting of the bit strings 0, 1, and 1, 1. So we know that our grammar G is going to be a 4-tuple with components V, T, S, and P, where V is the vocabulary, T is a set of terminal symbols, S is the start symbol, and P is the set of productions. So I'm actually going to identify the set of productions first, and then I'll use these to find V and T. So to obtain the bit string 0, I want to include the production S produces 0. To obtain the bit string 1, I want to also include the production S produces 1. And to obtain the bit string 1, 1, we want to include the production S produces 1, 1. So we have 3 productions, and we see that our vocabulary V is going to include 0, 1, and the start symbol S. And the set of terminals is simply going to be 0 and 1. Now, in part B, we are given the set of bit strings containing only ones. Once again, our grammar G is a 4-tuple with components V, T, S, and P, where V is the vocabulary, T is the set of terminal symbols, S is the start symbol, and P is the set of productions. So to determine our vocabulary first, I'll determine the set of productions. We know that our set of terminal symbols is going to be simply 1, since our strings are only going to contain ones. Now, to obtain the set of bit strings containing only ones, we'll want to include, well, we could have an empty string, so we'll want to include the production S produces lambda. And we also want to include the production S produces 1s. So this enables us, with this along with lambda, to produce any string of arbitrary length, which is all ones. And so these are all the productions we need. And we see that our vocabulary is simply going to be the set 1s. In part C, we are given the set of bit strings that start with 0 and end with 1. Once again, our grammar is a 4-tuple. Components V, T, S, and P. We have that our set of terminal symbols is going to include 0 and 1. Since it is a subset of the set of bit strings that includes both a 0 and a 1. Now, in this case, we have that the empty string is not going to be included, so we don't want to have the production S produces lambda. However, we will have the production S produces, 0, A, 1, where A is a non-terminal symbol. So this way, our string is going to start with a 0 and end with a 1. And we want A to be able to take any value in between. So we see that we should include the productions A produces 0, A produces 1, A produces 0A, A produces 1A, and then if we ever want to stop, A produces lambda. And this way we generate all strings which start with a 0 and end with a 1. And so our vocabulary is going to include 0, 1, A, and the start symbol S. In part D, we're given the set of bit strings that consist of a 0 followed by an even number of 1s. Our grammar G is a 4-tuple with components V, T, S, and P. T is going to be the set 0, 1. And we're going to let a non-terminal symbol represent the pairs of 1s, so that our productions are going to be S produces 0A. This is because our string must start with a 0, and in fact only one 0. And after this we have that we can only have an even number of A's, so we follow this with the production A produces 1, 1A, and then A produces the empty string lambda. And in this way, we're only going to be generating strings which start with a 0 and end with an even number of 1s. Notice that we could have the string 0, which does have an even number of 1s. It has 0 1s. And so we see that our vocabulary, in this case, should be 0, 1, A, and S.